Okay, so in the first part of this tutorial we had simply defined a drawing function that takes a given string here, given in a variable, and draws it. So that was that function in the look section, drawString, that we wrote. Now in the second part what we want to do is we want to define the actual rewrite system so that we can just take a grammar, run it, get the string from it, and then use those functions to draw it on it. Okay, so the first thing is obviously we need to get our rules into the system, and we also need to get the starting string into the system. Let's define two variables to capture that. Call one start string, and we call the other one rules. Okay, so the rules we will fill with those rules here. Let's go back to our lesson for that simple tree here. This is what the system looked like up here. So there are two rules. To represent two items, we will need a list of two items, each one being a rule. But then each rule itself consists of two items, the stuff that's on the left of the arrow and the stuff that's on the right of the arrow. We don't need the arrow, that's always there. So let's do that, and we use lists to represent all of that. So one rule there was, let's look again, a 1 goes to 1, 1. So we can take a list that has a 1 as the first element and 1, 1 as the second one. And that's all that we need to know. First one tells you where you come from, second one tells you what you make from it. That means our other rule could be represented in the same way. 0 goes to 1 bracket minus 0 bracket plus 0. Make another item. 0 goes to 1 bracket minus 0 bracket plus 0. Okay, so we have these two. To package them, we take another list structure. So we've got nested lists here. That's my first rule. That's my second rule. And now I can just set the variable rules to this. Run it. Okay. I can get rid of that. I don't need to have it hanging around because I've already set my rules here. And we're finished with that. We don't want to change that for now. We also need to set the start string. Let's look again at our lesson what the start string was. Well, we use different versions. Let's use this one down here. Minus minus 0. So we set start string to minus minus 0. We run that. Start string set, we can get rid of that. Okay, so we're now ready to define our rewrite function. We are in the variable section, so we can go to the make a new block, and we define rewrite. And because we usually apply the function several times for a Lindenmayer system, not just once, you have a certain number of repetitions, we start with only rewriting it once, and then we call that repeatedly. So rewrite once is our new function. Where shall we put that? We could put that under operators, for example. And it is a command because it does something, it doesn't return anything, it just draws something. What do we do in the function rewrite once? Well, we'll always translate a string that we already have into a new string. So first thing is we'll probably need a variable, a script variable that only exists in this script for the new string as we build it. And because we need to go through the old string position by position to apply a rule to every character in the old string, we also need an index variable that allows us to step through the string. So just like before, to step through the string, we use a repeat until loop. you may remember from before, we simply tested whether the index was greater than the length of the string. So repeat until the index is greater than the length of the string that we're processing. That's here in the variable section. And of course, we need to increment in each run of the loop, we need to increment the index variable by 1 so that we're processing the next position. So set, it's a local variable. Sorry, the reason why you can't use that right now from here is because it's not connected. So it doesn't know that variable because it only lives in the script. So it will only know it when it's connected to that part of the script. See, now it's appeared. Set index to index plus 1, get the plus operator. Index plus 1. And we need to process that position that the index points to. So the letter, we've used that before, letter index of string is what we're looking at. Now what do we do with that letter? What do we do if we see, for example, a 0? We want to apply the rule, right? So we need to find somehow this here, the second entry, so the right hand side, what's after the arrow of the rule. And I don't want to worry about that now. So what we'll do, instead of worrying about it now, and there's a typical thing in programming, you just say, I'll worry about that later. So I say, I make another block, which is an operator, which will give me the right hand side back. I call that RHS for right hand side. And it will obviously need to have one input. And the input is the left hand side of the rule. And then it will just give me the right hand side back. And for now, I'm not going to worry about how I do that. I just assume I can write a function that does that, right? Postpone the trouble. Okay. We've done that. So, but now we actually have a function here, even though it's not yet defined, that says I can just get the right-hand side for the letter that I'm currently looking at. So the right-hand side is what I need to put into the string at that position. So I take the new string from up here, and I append the right-hand side to the new string, the next position that I've processed. So I need this join function. Whatever I get back from the rule application, I join with what is already in the new string, and I set the new string to that. So I get the set function, set new string to joining whatever we have already in the new string with that right-hand side of the letter. And I actually need to do that before I increment my index variable, because otherwise I will never looking at position 1 if I instantly increment that. So turns out we have actually not initialized our index variable at all, so we need to do that as well. Set index variable to 1. Repeat for every possible index position. Set the new string to whatever we have in new string already, plus the right-hand side of the appropriate rule, and then increment the index and continue until you're finished with the whole thing. And of course, then in new string we have the result, so we need to return that. And so what we need to do now is we set the string to whatever we've computed in new string. We're done with the old string. So go to variables, set string to new string. So we've processed the whole string. Okay, that's it. We generate two string variables for the new string and for the index to run through the old string. Set the index to 1. For each possible index position, we first get the right-hand side of the letter that the index points to, and we join that with whatever we have in new string already. And the index gets incremented. We do that until we run out of index positions and point behind the string, and then we set whatever we have obtained in new string as the value of the main string. Now, seems like we've forgotten something, namely we've never started with an empty new string. We've set the variable, but we don't actually know what it is, what its value is, and just like we set the index position to 1, we also need to set new string, we need to set, my mouse doesn't want to do it, I need to set new string, doesn't know it because it's not connected, it's a local variable, set new string to nothing, just to empty, and we're done. Of course, so far nothing is going to work because we had postponed defining the right-hand side operation. So let's do that now. Right-hand side is down here. Control-click on it, edit the block definition. Make that a bit bigger. Okay, so what do we need to do in there? To find the first thing is we need to find the rule that applies. So, for example, if we have LHS, left-hand side is 1, we need to find here the second item. This is a list, so we need to iterate through the list, just like through a string. And by now you know the drill. What we'll need is we'll need a script variable for the index. Call it I. And of course we need to initialize that script variable to the first position. Then, as always, you've seen it 3 times by now, we iterate in the same way. We repeat our search until we've run out of index positions, so until the index I is greater than the length, where is it? Down here, the length of the rules definition. Each item is 1 rule, so we want to iterate over all rules. That's our variable rules up here. So until I doesn't have any rules anymore to process, we repeat this. What do we do in there? Well, as in every iteration, let's make sure that we're actually incrementing our script variable for the index. Not that we'll forget that later. But that's of course not the main action. The main action is that we want to check whether we're at the right position. So we want to check whether the first entry in the rule is the left-hand side that we're looking for. So we need a comparison. And we compare to the rule that we're looking at, which is given as the ith element. In the variable section, item I. Need to do that in the script though, because we need a script variable. So let's make this first. We want to compare the left-hand side to something. Now, to use that comparison, we need a if, of course, a control. And this time I will take the if then else, because if the comparison actually applies, what we'll be doing is we're just returning the right-hand side. If it doesn't apply, we need to increment the variable and proceed with the next rule. So that's why we need an if then else, a case distinction and not just an if. Okay, so we were looking at item I of rules. But item I of rules, look at what that is. So for example, item 1 of rules is the complete rule. And we only want to compare, obviously, to the left-hand side. So to the first item. So item 1 of rules here, item I of rules here is a complete rule. But what we actually want is the first item of that rule. So we wrap another item 1 of all of this around it. Put that back. So we compare to the ith rule, but only to its first item, which is that column here, and check whether that is the left-hand side. And if it is the left-hand side, well, what we want to give back is here the second item. So exactly the same as this. Duplicate that. But the second item, which is the right-hand side. Right? And we want to return that, and that's done in the control section with the report, just down here. And then finally we need to finish that off. Okay, so we need to complete that. So if we have not found a rule for that item, what's the action to do? Well, the action to do is to leave it unchanged. If there's no rule, by default we leave the character unchanged. And in the script, what will happen is, well, if we don't find it, we finally run out of iterations here in this repeat until block. And we only do that if we don't find a rule. We know that, so we come to this spot down here. And that means we can just return the left-hand side because we leave it unchanged. And that's what we had to look for. So we're done. So we have a script variable I that we initialize to 1, and that is our index into the rule table. We run with a repeat loop through all the indices until we find one rule, item I of rules, where the first item here is the left-hand side that we're looking for. If we find that, we report the second item of the corresponding rule as the result. And if we run out of options, that means we haven't found a rule for it, we just give the unchanged left-hand side back. And we're done. So let's test whether our functions actually work. To be able to test that, the first thing that we need to do is we need to set the string to the start string, because that's what we're operating on. So let's do that manually. Set string to start string, and let's display the string again so that we know what's going on. That was our -0. We can get rid of that, or we can let it hang around. And now all that we want to do is we want to call that rewrite once that we defined earlier. So we just click on it to call it. Oops, that didn't quite work as expected. So what does it say on here? It stays red, which means it hasn't finished. It says inside error, a variable of name quote does not exist in this context. So a variable that has no name. That sounds like a strange thing. Let's look into the function. What have we done wrong? Control click, edit. Let's go through the blocks one by one. This looks fine, fine. Set index to 1. Oops. What is this? Set nothing to empty. Okay, so this is actually a variable that doesn't have a name, which is exactly the complaint in the error message. What did we intend to do here? We intend to initialize both script variables, the index to 1, we've done that, but we've forgotten to actually define that we want to initialize new string. We hadn't specified which one. So we set new string to nothing, to empty. Let's try whether that works a little better. Let's click it again to execute it. Yes, now we've got it. Okay, so set start string, we set that, rewrite. So rewriting once actually works. So the next thing to define is how to repeatedly apply that, because remember, that's what we do in a Lindenmayer system. Okay, well, that shouldn't be too hard, I guess. So we just make a new function. You're getting used to this, I presume. Make a new block. We call it rewrite, and that will use rewrite once. Put that into the operator section. It's a command because it does something. Okay, so what does this command do? Well, one thing that I will definitely have to do is what we just did manually, namely setting the string to the start string. We may actually want to initialize the other variables here, also in this function that we've done before. So let's do that. We set the start string explicitly to the value that we wanted. So no matter what it is before, we can always write that run that function, and maybe we want to set our rules in here as well. By now we know how to do it, so let's do that as well. We want a list for the rules. We wanted 2 rules, so let's extend that by 1. Each rule itself is a list with 2 items, namely the left-hand side and the right-hand side. One rule was 0 goes to 1 bracket minus 0 bracket plus 0. The next one was a 1 goes to 1, 1. Done with that, we set the string to the start string, and now all that we need to do is a repeated application of the write once function, rewrite once function. So we just repeat that a fixed number of times. Let's say we repeat it 4 times. And we take rewrite once in there. And we're done. Set the start string, set the rules, set the string to the start string, and repeat rewrite once 4 times. Let's see whether that works. And to see that all our initializations work, we'll actually destroy the values in all of these variables. So we say set string to 0, set start string to 0, set rules to 0. All completely unusable, but our function should initialize this correctly. We say rewrite. Maybe we also want to clear the display just to see what really happens. Let's see. It's still rewriting, the string's getting longer. Okay, it's finished. You see that because the block down here isn't highlighted anymore. So we should now be able to apply our draw function that we defined earlier, which is in looks, draw string. Yes, we're done. So it looks like we don't need the variables to be displayed anymore. Let's wrap this up into one function. Let's call it LSystem. Where do we put it? Maybe it draws something into the look section. And what LSystem does is it first rewrites, which was in the operator section. everything, then it uses our draw function to draw the whole string, and that's the lot of it, and should probably clear the screen before. Let's go. Let's check that. Screen cleared. You see it's still running because it's highlighted. Now it's rewritten the string and it's drawn it. Great. And if we wanted to know what the string is, we can just always look at it up here. Done. Congratulations, you've written a whole L system interpreter now, and that's a pretty good feat. Congratulations. So with what you've written now, you have a little lab that you can use to experiment with L systems. So let's do that. For example, let's look at our rules. We had zeros and ones, right? And if we go back to the process character or draw character, now we call it process character here. Let's look at what zeros and ones meant. They both meant move 10 steps forward, draw a short line segment. But if you don't really understand how the grammar works just by looking at it, you can now simply experiment with it. Let's make them different colors and we'll find out what they actually are. So we just go into the look section, sorry, into the pen section, and we set the pen colors for each of them to be different. And let's say our zeros are green and our ones, sorry I put that in the wrong spot, of course it needs to be in the if letter equals 1, are blue. Right? So we've just changed their color, zeros green and ones blue. Let's see what that leads to. Let's execute the string. Okay, so what we've found out are that the zeros are these end segments. Maybe we want to edit our grammar a little bit and extend that a little bit. Maybe we want at the end of those end segments we want little buds. Let's say we want red buds. Let's do that. So the first thing that we need to do is we need to add something to the grammar. So we defined our L system in the rewrite section. So let's say behind every 0 we add a 2. 0, 2 plus 0, 2. And to define, of course, what a 2 means, we need to make that a character that we can process. So we need to extend here our definition of process character. Edit that. So we've got an if letter equals 0, if letter equals 1, so we just put an if letter equals 2 in there. And let's say what we want to do there is we want a red bud, so let's first change the color to red. And move 10 steps is obviously not what we want to do, but instead we want to put down a little circle. So the way we do that is that we put a stamp there. And a stamp means that we're just imprinting the shape of the turtle. Now that doesn't look like a bud here, that's currently this triangle symbol that you see here and here. So we'll leave that for a second, we'll come back to that. We need to go into this section and reshape what our turtle looks like. And the different shapes of the turtle are called costumes. To make a new costume, I'll just click on this paint button here. And now I can, for example, just take a circle, make that a small circle. I take my fill color. What did I want? I wanted red. Fill symbol, click into the circle. Now I have a red filled circle. Also need to set the coordinate of the turtle, which is right in the center of that circle, and I'm done. So I get a new costume for my turtle. It can look like this now, and the costume is currently the costume number 1. They're all numbered. I could name it somehow, so rename that into Bud. So all that I now need to do is I need to, before I stamp it, switch my costume to that Bud. So let's go back to the looks. That was in process character, edit the block definition, and here we need to change the costume. So that's in the looks section, switch to costume Bud. Okay, so if the data is 2, we set the pen color red, we switch to the Bud costume, and we stamp that Bud costume there. And we've changed the grammar so that every 0 symbol now has a 2 at the end as well, or is followed by a 2, so we should get buds there. Let's see whether that happens. Just call lsystem, rewriting, and drawing. Fantastic, except for our buds are probably a little bit big. That looks more like a 70s wig really. So let's go back and make them a little bit smaller, and of course we do that in process character, edit. So we just reset the size here, and that's in the look section here. See, set size to percentage, put that in there. Let's say maybe, what, 20% will be about right, 10%. Let's try 10%. Okay, apply the lsystem again, and in the meantime you see how the rules now have the 2's in here. Beautiful. There's our little cherry tree. Okay, and so in this way you can experiment with the grammar, you can experiment with the way the grammar is drawn and everything else. Be creative, try the examples from the lessons and try your own examples, explore, enjoy. Actually, one final note, you may want to save your work every now and then. So one way to do that is there are actually 2 different ways of doing this. And one way in the web app to do that is quite simply to click on this document item here and you say save as, and you see I've already saved it there, but let's save it as something else, say test lsystem. Whoops, system. Save it, and where it gets saved is in your browser. It doesn't get saved on the disk or anywhere, it's directly in our browser. So the next time you call the web app, it's there. You just go here, you say open, and you've got it there. Another way that's more permanent, and particularly if we want to send it to someone else, is also via the document icon up there. Go to export project, and you see there's a download here, which is an XML file, and you can just take that XML file and give it to anyone else. And if you want to import that, you go up here, import, and then it will ask you for the file, and you load an XML file like that you could have gotten from someone else, and you've got the complete project in there. So, save early, save often. Bye.